air compressor. Air compressor we all know, because in the chapter gas turbine we discussed the role of a air compressor. So a air compressor basically it converts the power into potential energy. So we have to supply power to run a compressor. That means it consumes the power. Okay, a turbine develops power, but a compressor consumes power. We have to run a compressor by any prime mover, any power source. Generally, it is done by an electric motor. And what is an electric motor? Electric motor converts the electrical energy to mechanical energy, and that mechanical energy runs the compressor. And basically, what is the function of a compressor? It compresses air or any fluid. Generally, we use it for, in maximum cases, we use the compressor for compressing the air for different uses. So in this chapter, we'll discuss air compressor, introduction to air compressor, classification, terminology, what are the terms used in the air compressor. We'll discuss the single stage reciprocating air compressor, its construction and working, how it works, and that we'll discuss only with respect to the line diagram. Also we'll discuss we'll try to solve derive some expression for work done. Okay, derivation of the work done by a single stage reciprocating compressor without clearance volume. Clearance volume you know already in the IC engine, same clearance volume. That means clearance above the piston in the cylinder head. So I am talking about single stage reciprocating compressor. It works like a IC engine itself. That means there will be a cylinder and piston. And also we will discuss with clearance volume by using PV diagram. Okay, we will take the help of a PV diagram to derive the expression. And we will also discuss how multi-stage compressor is helpful for us, what are the advantages and disadvantages of multi-stage compression. In the gas turbine, we discussed that we use two compressors. So that is what? That is basically multi-stage compression. Compression in two stages. And also two-stage reciprocating compressor with intercooler. In between, we will use the intercooler. Simple problems for work done and power required to run a compressor. Okay, already I have mentioned that air compressor is used for many different purposes. Now the use may be in the construction field, it may be in the manufacturing field, industrial applications. It is also used in main agriculture field and also in energy sector, and in some cases heating, ventilation and air conditioning. These are some areas in which air compressor is used. Okay, application, field of application. Now if we say construction, in construction site we need some pneumatic tools. Pneumatic, you know, work based on the fluid pressure. Some equipments and tools use some pneumatic principle, and for that a compressor may be useful. It is also used in drilling in the construction site, and some handling of some equipments from heavy things can be handled with the help of a compressor, and also for the lifting of heavy weights. And it is generally used also for powering portable tools. Some portable tools can be given more power with the help of a compressor. That means compressor means high pressure air can give the power. It has the power to do work. And in manufacturing field, it is used in diverse fields like plastic industries, metal fabrication, food and beverage, and also in pharmaceutical packaging industry. It has a huge use in packaging industry. Now in conveyor belts and so, these air compressors are used, and we all know to spray something, the compressed air can be used, so we need a compressor. And in pressing something and packaging also, all packaging thing we get for that we need one compressor. In agricultural field, we know that tractors has some multiple uses. In that case also compressors are used. And then in the sprayers, to spray the medicine, insecticide, pesticide, etc. Also to give crop conveyor, that means to spray the crop seed. For that type of things also compressor can be used. Okay, this is in agricultural field. Now in energy sector, where energy is produced, for example, oil drilling extensively used air compressor, and any other drilling rig or task, compressor can be used. So these are in short some field of application in which the compressors are used. For heating, ventilation and air conditioning, we know we have a refrigeration system that is called the vapor compression refrigeration system. After this chapter we will discuss that thing, refrigeration and air conditioning, that is a separate chapter itself. So in vapor compression refrigeration system, in most of the refrigeration system, compressor is required. All freeze refrigerators need one compressor. And similarly heat pump system, heat pump we know, heat pump same, need a compressor for input, and that means we need one compressor. Now the classification of compressors. Okay, compressors can be used to compress any fluid, but we will discuss it for the air compression system. Now to compress air, there are two types of compressions basically, that is the positive displacement and rotodynamic. So in positive displacement it pushes the air, okay, and in rotodynamic it gives some imparts some kinetic energy. Initially it gives kinetic energy, and that will be again diffused. In the last few classes we talk about diffuser. So the kinetic energy is imparted by an impeller or so, and that kinetic energy is converted to pressure energy with the help of a diffuser. So these are the two basic classification. One is positive displacement, that means the air is pushed by force, that is positive displacement. Then again positive displacement, there may be two main types of positive displacement type air compressor. One is reciprocating air compressor, that means this principle is like IC engine, reciprocating, okay, to and fro. Slider crank mechanism is used in reciprocating. And in rotary air compressor with positive displacement, generally some helical screw are used. Okay, two matching screw are used to compress the air, and you may have seen the principles in some mustard oil scraping machine. You have seen there two helical screws are used. So the air passes through the screw and it pushes the air, and accordingly it will be compressed in the next stages. Okay, so the movement is rotary movement, that is why it is called rotary positive displacement, but rotary. And this is reciprocating movement, that is why it is called positive displacement air compressor, and that is the reciprocating air compressor. And for rotodynamic, in which the kinetic energy is converted to pressure energy once again, principle may be centrifugal. The flow is centrifugal. The impeller forces the air in the centrifugal direction, that means in the direction of the tangent of the impeller. And in axial flow, you might have remembered that in steam turbine we discussed axial flow steam turbine, in which there are some fixed blade and moving blade. That type of principle, same principle like that turbine, but the blade angles will be different, some construction or design thing will be different, but for so far as principle is concerned, this is same. The flow is axial, that means the air flows in the parallel direction to that of the shaft, but in centrifugal compressors air flows in the tangential direction. That is why it is called centrifugal air compressor. But in this chapter we will only discuss about the reciprocating compressor. From your content we will discuss the reciprocating thing only. Okay, how it works, that means single stage, double stage, or anything like that. Okay, now we are aware that compressor needs external work input to run this. That means we have to supply the work to the compressor to work. So suppose this is a compressor. So what the compressor will do, we are talking about air compressor. So it will take the air from the atmosphere. Okay, so atmospheric air will be taken into the compressor. Whatever the compressor may be, it may be reciprocating, it may be anything, centrifugal or anything. So it will take the air from the atmosphere. Now it will compress it. Now we all know that when we compress air, the pressure decreases, pressure increases, volume decreases, and in this process the temperature increases according to the gas law. So if we compress air, then definitely the temperature of the compressed air will be high. So out of this high temperature, a part of this heat will be lost to rejected to by radiation itself, or we can arrange some cooling arrangement also. For efficient working of the compressor, we may have to cool the compressor, then the efficiency increases. Okay, so there may be, and if we do not have any cooling arrangement, then also the heat will be lost by radiation from the compressor chamber itself. Okay, and the compressor will deliver the compressed air to some system, say to some receiver, to some container, and the compressed air will go out of the compressor, and it may be preserved somewhere, or it may be used immediately. It may be used for the work that is intended for. Okay, now while doing so, I have mentioned that compressor needs some external work input. So we must run the compressor. So for that we need one power input. That means work has to be inputted. If we say it is WC, or we can also say W in, that means work input to the compressor. Now where from we get this work? So we may use a prime mover. Okay, a prime mover we already know. So a prime mover produces power, and that power may be used to run the compressor. So this prime mover will run the compressor. So sometimes we use, already I have said that we may use one electric motor, but that is same. That means we need some work input. Now again, just let me mention what is a prime mover. Basically, in terms of heat engine, we can say a prime mover is a device which takes some work input and rejects which takes some heat as an input and rejects a part of this heat, and rest is converted to work. What is W? W is equal to Q in minus Q out. So this way, this is the basic principle of a compressing system. Okay, it needs some work input. Now, we will discuss only reciprocating compressor. So definitely if it is a reciprocating compressor, definitely it will have piston rod, cylinder, connecting rod, crankshaft, crosshead, everything will be there like an IC engine. And similarly there will be inlet and exhaust valve. Only thing is that in IC engine compressed air is used for burning the fuel, but in this case the compressed air will be delivered to the receiver where it will go and will be preserved or used immediately. So you look at this diagram mechanism. So this is the crank, this rotate, and because of this crosshead will reciprocate, and with the crosshead there is one piston and piston rod. So this is the piston. So piston moves in a to and fro motion. So this side will be TDC and this side is BDC. So since the temperature increases because of the compression, there may be some cooling jacket may be there. Okay, it may not have, but in this diagram it is showing the blue things are cooling jacket which carry away the heat produced during the compression. Okay, just see if the piston this is the inlet valve, say this is inlet valve. So when the piston moves from TDC to BDC, this is like suction stroke in IC engine, the air will enter into the cylinder. And in the next stroke, when the piston moves from BDC to TDC, and the inlet valve will be closed as well as the exhaust valve will be closed, and the air will be compressed. But towards the end of the compression, this delivery valve or the exhaust valve will open and the air will go out of the system. That means it will go to the receiver, wherever it may be preserved for future use or it may be used immediately. So basically, what are the components of a reciprocating compressor? There will be one cylinder, one piston, connecting rod, crank, inlet valve and exhaust valve, and definitely there will be one cross head for proper to and fro motion. In between there may be one cross head. So that is the principle. So what happened? There are two strokes. One is suction stroke and next is delivery stroke. Compression as well as delivery. At the end of the compression, it will be delivered to the receiving system. What type of thing? What will be delivered? Air. And what type of air? The compressed air will be delivered. Okay, and again after the delivery, both the valve will be closed and exhaust valve will be closed and inlet valve will open and the cycle repeats. So in fact, it is easier to understand the principle than the IC engine. Okay, in this case there are two main stroke and two processes. One is suction and next one is compression and delivery. So there are some important terms we have to understand. Reciprocating compressor may be single acting. What is a single acting? If the air enters in at one end of the piston, that is called single acting. Sometimes the compression may take place on both sides of the piston. Okay, that is also possible, that we will see how it works. So then it will be called double acting. That means when the suction stroke takes place at one end, at the other end it will be compression and delivery. And in the next stroke it will be opposite. Similarly, there may be single stage compression or multi-stage compression. That means multi-stage compression means there will be more than one compressor. That means one compressor means one stage of compression. Two compressor means there will be two stages of compression. That way it can be classified. And there is another term. Let us see one by one. Free air delivery and displacement or swept volume. Now you see, Okay, suction takes place, and after some time, after compression, it is delivered or discharged. Crank and lever, piston and crank mechanism. Okay, suction, compression as well as delivery. Suction, compression, delivery. So what is this? This is the air is entering at one end of the piston. So this is single acting reciprocating compressor. Now just imagine if air enters at right side of the piston also, then it will be double acting thing, reciprocating compressor. So that is also possible. So let's see how double acting compressor works. You see, that blue thing is say air. Air enters at one end, and in the next row, air enters at the other end. So this way, there will be, it will give more air, more compressed air, because the power used is utilized for compressing on both end of the piston. That is why double acting. Like say something you are doing with one hand, and if you can do at the same pace with the help of two hands, then your power will be different. Your capacity will be double. That type of thing. It acts on. It is said double acting reciprocating compressor means the air acts on both sides of the piston, left or right, or you can say top and bottom. At both ends, the air act. It will push. It will air enter into both ends of the piston. Next is single stage. So I have already mentioned this is a compressor. Air enters and compressed, and this is run by a prime mover. So this is single stage compressor. Okay, just one compressor, and it compresses and delivers to the system whatever it is necessary. Now what about double acting? Not double acting, multi-stage. So this is a two-stage compression. Air enters into the system, first stage of first compressor, then this compressed air is not used immediately, but it will enter into the second compressor, and it is then delivered to the required place. And this is run by one prime mover. In both the cases, it is run by a prime mover. So this is called double stage reciprocating, double stage compression. It may be reciprocating, it may be the centrifugal, no issue, but the process is called double stage compression. If there are three compressors, then we will call triple stage compression, and general name is multi-stage compression. Now let's understand the free air delivery. This term is very important in this chapter. So what is this? This is basically the capacity of the compressor, and how it can be defined. It is the actual volume delivered at the stated pressure reduced to intake pressure and temperature and expressed in cubic meter per minute. So what does it mean? Actual volume delivered at the stated pressure. So a compressor is designed for a particular pressure. Say for a pressure P is equal to 10 bar or so, anything. Just for example, I am taking this number. So P is 10 bar. So after compression, the pressure will be 10 bar, but temperature will be something, and temperature will increase. Now if this air, whatever with the volume, is converted to P is equal to, say this is P2 is 10 bar and P1 is what? The What is P1? P1 is the pressure before compression. So if we convert this to what will be the volume if pressure is P1 and temperature is T1. After compression, pressure is P2 and temperature is T2. So that has some volume, and that volume is say V2. Now if we convert what is V1 at P1 pressure and T1 temperature, then that quantity will be called free air delivery. Okay, this is called reduced to intake pressure and temperature and expressed in meter cube per minute. That is called free air delivery. Free air delivery, FAD. The insert it is called FAD. Okay, FAD term is displacement or swept volume. You all know about this. What is displacement or swept volume? What is that? That like IC engine, the volume displaced by the piston movement between TDC and BDC. So the distance between TDC and BDC, that volume is called the swept volume or displacement. We all know the formula also. Vs swept volume equal to pi by 4 d square into L. L is the length of the stroke. So these are the important terms. What are the acting, single and double acting, single and multi-stage, free air delivery and displacement or swept volume. Now the compression, there may be different type of compression, but we have discussed about isentropic expansion. Say this is an adiabatic compression, PV to the power gamma equal to C. Okay, so at the left side you see piston is in BDC and this is the position of TDC. So this is TDC and accordingly this is BDC. Piston moves from TDC to BDC and BDC to TDC. When the piston compresses, what is the stroke? From top to bottom or bottom to top during compression? So these things we do not need. Okay, we are taking this diagram from some other places. Actually, we are interested in process 1, 2 only. Process 1, 2 is compression. We all know in gas turbine also, in steam, in IC engine also, we know what is an isentropic or adiabatic compression. Its volume changes from V1 to V2. Volume decreases, and PV diagram you can see pressure increases to P2. From P1 it is increasing to P2, and that is called a compression. And this process is what? This obeys the law, say PV to the power gamma equal to constant. That means adiabatic compression. So we also know the area under the curves represent what? The work done. So what is the area for process 1, 2? Process 1, 2, this green colored space area is the area under the curve. So this area represent what? The work done on the compressor, or we can say work input to the compressor. Okay, this area. Now if we can find this area, that means that is the work done. Okay, say point 1 is this is point 1, piston is in BDC, the valve are closed. Now in this stroke the piston will move towards the TDC, and accordingly this air will be compressed and it will go up to point 2. That means this point is 2. Okay, this point is point 2, and this is shown in this PV diagram, it is point 2. So in the PV diagram, point 1, 2, process 1, 2 is adiabatic compression process, and the area under the curve 1, 2 represent the work done on the compressor during the process. Okay. Now if we look at this, out of these 3 diagrams, three lines processes, you can see, so this is isentropic, okay, P V to the power gamma equal to C. That means we know there is other processes, that is, one is polytropic processes in which P V to the power n equal to C, where n is the polytropic index, and this is isothermal process in which PV equal to C. Isothermal means PV equal to C. So in this case, n equal to 1 for isothermal process, n equal to gamma for isentropic process or adiabatic process, and n is the polytropic processes. Okay. So in compression, there may be the compression process may be adiabatic, or it may also be isothermal, and generally the processes are between isothermal and isentropic. This type of there may be any number of processes between n equal to 1 and gamma. So value of n may be less than gamma and greater than or equal to 1. In practice, theoretically we can say n equal to 1, n equal to gamma, but this is only theoretical thing, because no system is 100% isothermal, no system is 100% adiabatic. That means in actual practice, the value of n will be greater than 1 but less than gamma. Gamma is 1.4 for atmospheric air. This is isentropic and this is isothermal, and this is called polytropic n. So n may be between 1 and gamma. Okay. Now suppose this is the PV diagram for two-stage compression. What are the stages? First stage is 1 to 2. This is the first stage compression, and second stage is 3 to 4. This is second stage. Okay, from 1 to 2, again 2 to 3, that is another process. We are going to explain what is process 2, 3. Now process 1, 2, in actual practice during compression we may do two things. We may spray water on the compressor. That way the heat will be carried away by the water, spray water. That means it may tends to be isothermal. If we continuously spray water on the compressor, then what will happen? Continuously the heat will be carried away by the sprayed water. That means the compressor will remain at constant temperature. So that way we can make or try to make the compression process isothermal, and this can also be done by using some water jacket. So what is the function of a water jacket? Water jacket are the space or passes for passing the coolant through the jackets, and this coolant, it may be water or anything, this coolant will carry the heat away from the compressor. So this is same like water spraying. So that will also make the process close to isothermal. So the water coolant will carry the heat from the compressed air, from the compressor, and that way it will keep the compressor at constant process. Okay, that is the way we can do for process 1 to say. For process 1, what we can do? We can make it isothermal, or if we do not do anything, then it will be something like adiabatic, but close to adiabatic, not isothermal, not adiabatic. That type of thing will happen. Now if we use two stages, say process 1 to 2 is first stage compression and process 3 to 4 is second stage compression, but in between there should be an intercooling with multi-stage compression. Multi-stage means in this Example, we take two-stage compression. Process 1, 2 is first stage compression. Process 3, 4 is second stage compression. And there will be is one intercooler, and that intercooling is process 2, 3. Now you see in PV diagram from 2 to 3, what happened? What about the volume in process 2, 3? You can see from the yes.
Volume to decrease.
Good. So in PV diagram, only thing we can see pressure remain constant, but volume decreases from 2 to 3. So that is the thing. If we cool something gaseous, that means compressed air, then the volume will decrease. Then after decreasing the volume again, that means cooling, that definitely what the temperature will decrease. Because the process is intercooling, that means cooling means low, it will decrease the temperature. But at that same time, in PV diagram, we can observe that the volume will also decrease. And after intercooling, we do the compression, second stage of compression. Okay, and this way in actual practice we can run compressor. By what way? We can spray water on the surface of the compressor, and that will carry away the heat continuously, and that will bring the system near to the isothermal. Also we can use water jacket, that will also keep the temperature constant, that means isothermal. And for two stages, we definitely need one intercooler for two stages, and that intercooling is represented by process 2, 3. That means this is what? This is basically a cooling process. And other than this, if we do not do this type of thing, we are not spraying water, we are not using any water jacket or water cooling, we may simply use external fins. And fins we have discussed in details to some extent in IC engine. So what is the function of a fin? A fin is the arrangement for larger surface area, and that helps dissipation of heat to the atmosphere. The heat transfer will be faster because of use of the fins. So in the compressor surface we can use fin, and probably you have noticed that, and there you can notice there is one compressor, and in those type of compressors you will see that external fins are used. That means that is air cooled, and that is also a cooling system. But the only thing is that cooling may not be so effective like water spraying or water jacketing, but that is also a cooling system. So this way we can run the compressors by intercooling, by water jacketing, by water spraying, or also by using external fins. Isentropic. So let's consider a single stage compressor with isentropic compression. So from PV diagram you can see 1, 2 is PV to the power gamma equal to constant. That means this is compression, and this compression is isentropic or adiabatic compression. Now 4, 1 is suction. The air is taken inside the cylinder. 1, 2 is compression, and you see 1, 2 is compression means the piston is moving from, this is actually BDC and this is say TDC, because there is no clearance, zero clearance. Okay, so TDC, there will be no TDC clearance. So TDC is at the top of the cylinder. So after suction it is compressed only to volume 2, but rest of the movement of the piston is used for delivery. So 2 to 3 is delivery. We will not say this delivery stroke, but the process is delivery at constant pressure. That means the compressed air is delivered to the receiver. It will enter into the receiver or container, whatever you say. So 4, 1, 2, 3, 4. These are the processes. What are the processes? Suction, compression and delivery. Okay. Now, can you tell me what will be the work done during this process? How can we find out total work done in this system? So, for that you are aware of this. So, what is the work of compressor? How much work has to be done? In the I have already mentioned this is the area under the curve. Now, which area? Since the whole cycle is 4, 1, 2, 3, so the area will be 1, 2, 3, 4 and 1. That means this is the area which represent the work done on the compressor. Now, we can calculate this area. Now, thing is, we can make it much easier how to calculate this area. Okay. Which area? Area 1, 2, 3, 4 and again 1. Now, this area is equal to how much? So, we can say area AB23A. What is that? A, B, 2, 3A. So, these are the whole area. Plus what area? Plus BC. What is B? B, C, 1, 2 and B. That means this area. So, this way we include whole area, but we need the upper area only. So, we have to deduct this area, and that is what? A, B, C, D. A, B, C, 1, 4, 1. That means this area we have to deduct. Then what will be the area remain? So, this is the area remain. So, that way we can find out this thing. So, now just look at these areas. You can see what will be the area. First one?
AB into AT.
Good. কি কৈছা? A, B, 2, 3, A. Good. So, that is AB into
A3.
A3. Okay. Now, what is AB? AB is actually V2. And what is A3?
Yes, sir.
That is P2. So, it will be P2 V2 because this is a rectangle. Now, what is area BC12B? BC12B. For this, we know. We have already discussed in the 4th semester. This is what? We got a formula P1 minus P2 V2 divided by gamma minus 1 in 4th semester. Okay? For adiabatic compression or expansion. So, that formula we will use. That is the area actually. What is the area? BC12B. Now, you tell me what is this area? ABC14. ABC14. So, that is what? AC. That will be is equal to AC multiplied by this. So, this is actually P1 and this is V1 and this is P1. So, now you can calculate this area. So, first area is P2 V2, second one is P2 V2 minus P1 V1 by gamma minus 1 and minus what? P1 V1. You can simplify it. Can you simplify? So, this is the formula. We are going to do this. You see this calculation. So, P2 V2 minus P1 V1. You bring it within the bracket, and the rest is this one. Now, you can take common. P2 V2 minus P1 V1 is common, and then from this it is 1, and from this it is 1 minus common minus 1. So it will get gamma by gamma minus 1 into P2 V2 minus P1. Now we know P2 V2 equal to MR T2 and P1 V1 equal to MR T1. MR T2 minus MR T1. So MR common, T2 minus T1. Now from this, if we take the common T1, then it will be T2 minus T1 divided by minus 1. Okay, this is in terms of temperature, the work done on the compressor, or we can say work input to the compressor. In terms of pressure also we can find out, because the process is isentropic and we know what the isentropic law is. In isentropic law we got T2 by T1 equal to P2 by P1 whole to the power gamma minus 1 by gamma. So this is isentropic law. So we can put this value P2 by P1 and gamma. So this same formula, this is in terms of pressure and temperature also, but first one is only in terms of temperature. So this way we can calculate the work required for a compressor. But what type of compressor? Single stage compressor with what? With no clearance volume. Remember, we have not considered any clearance volume in this case. So there is zero clearance volume. But in the next class we will discuss what will be the work done for single stage compressor with clearance volume. Okay, this is without clearance volume. So what do we get? Work done on the compressor is equal to gamma by gamma minus 1 MRT1 and this. And also we can write in terms of pressure, also of course temperature P1. Gamma, we know what is gamma? Cp divided by Cv, and gamma equal to 1.4 for air. Standard value is 1.4. Now we discussed that the process may be isothermal or isentropic, but in actual practice the compression processes are neither isentropic nor isothermal. So it will be in between. So value of n may be anything. So in that case, for polytropic process, the value of n may not be equal to 1.4. Sometimes it may be 1.3, sometimes it may be 1.2, 1.1. So in that case, which formula we will use? This is the formula for polytropic process. In case same formula, n by n minus 1, MRT1, P2 by P1, n minus 1 divided by n. So this way you can calculate the work required for a single stage compressor without clearance volume. Okay. So that is within your syllabus. You should know how to find out this formula. Deduction is required for single stage compressor without clearance volume. Okay. So work required with clearance volume, this class we will not discuss it. We will discuss it in the next class. But by the time, if you have any question, you can. Air compressor introduction, classification, and some terminology. That's like free air delivery, multi-stage, single stage, intercooling, this type of things. And function of a compressor. What is the function? It takes in air, compresses, and delivers. In simple words. Then we have discussed single stage reciprocating air compressor, its construction, with line diagram. So in line diagram, what we have discussed? That it has a piston, it has a cylinder, it has a delivery valve, it has a inlet valve, it has a crosshead, and it will have a crank and crank mechanism. And expression for work done by single stage reciprocating compressor without clearance volume, and up to this we have complete with clearance volume by using PV diagram, that we will discuss in the next class, and these things also we will discuss in the